All right. Hi. What's up?
ODP 412.
Yes.
Is this a typo in the beginning here? If RC, it's got like less than and greater than.
Is not equal to.
Uh,
So what does it say?
Not equal to sign, but it has the less
It's got one
than
less
and greater than the sign instead of not.
Yeah. I think that's just what I was using for not equal to. All right, so yeah, that just means not equal to
Does the other
2.
way not work?
It's just,
Does typing it in not work?
yeah, you can say exclamation mark equal, but sometimes you say not equal to like that.
You can actually type that in.
No, not in C, but this isn't C, this is English, sort of.
I was thinking, that's why I was thinking.
Okay, yeah.
I thought it's greater than 2 and it's less than 2.
Let me make it C-like, because that is confusing. All right, and then there's less confusion there. Thanks, I didn't actually notice that I had done that. All right, yeah, so if it's not 2, do that. So I posted something from IT on how to put an Android device onto the 5 gigahertz network. On Windows, I think you just go to your network settings, and Izad sent me a blurb on how to do it, but they also said you can talk to the help desk. On Linux, I can just do iwconfig, and it'll tell me where I am, and it tells me very clearly frequency equals 5.2 gigahertz, and it seems to just kind of automatically select that for me. So whichever system you're using, eventually try to figure out if you're on the 5 gig or the 2.4. Okay, so some places use different SSIDs for high and low. That's how most home networks are set up. But they're all called the same, just student wireless or whatever it is here. So, but you can check it like that. So, if it's still a problem, let me know if you're having connectivity issues, and we'll find who you should be talking to about it. All right. Shout out for Clark Aerospace Club. How many people here are familiar with the Clark Aerospace Club? You want to be. It is the coolest club on campus, right? Even though I do the engineering club. This club just really rocks, okay? They build rockets. They shoot them up in the air. They go up 10,000 feet. Sometimes they explode. What more do you need to know, right? And they are largely mechanical engineers, and they need computer scientists and electrical engineers and all kinds of other disciplines to do their thing. So I'm going to leave that up there. I had Keith, the person who's sort of the faculty advisor for that club, I had him come to my CS class a few years ago. And yes.
When do they meet?
So they meet on Tuesdays 1 to 2 in AA4 room 204. And this says they also meet Wednesdays 1 to 2. So, okay, so there's 2 things going on. There's a team that's working on the rocket competition, and they meet on Wednesdays. And they've got something new, which is an autonomous drone and rover competition they're designing, and are going to compete a rover that I think is going to mine minerals from asteroids or something outrageous like that. And they meet on Tuesdays. But if you go to either of those, or I think generally any time during the day or possibly night, if you go to room 204 and AA4, you're going to see lots of people there working on all kinds of crazy things. And if you tell them you're interested in finding out about their aerospace club, they'll probably talk your ear off. But they design these things. They do all of the analysis. They do all of the CAD. And they build these things, right? They have some really, really awesome 3D printers that don't use plastic. I think they have a carbon fiber one or something equally ridiculous. They build these things and they mix up some of the fuels and they sew the parachutes. And I went there one day and there was this, like 30 feet of fabric and sewing machine, and they were sewing the parachute they were going to use for this thing's descent. And just a ton of software and electronics in these things. So there's always a mission. For example, you have to go up to 10,000 feet, and your goal is to hit exactly 10,000 feet. If you go too high or too low, you lose points, right? So you've got to have sensors, and you've got to have ways to change your direction, and you've got to come down and land within a certain distance of a target, and all kinds of stuff. So it's a really cool club to get involved with because they have some very, very specific missions, and they compete every year in these competitions. They compete against places like Stanford and MIT, and they do well. They do really well. They usually get recognition for at least a few areas of their effort. And a couple of years ago, I had Keith come to my CS class and talk to them about what they were looking for. And after he left, I kind of gave my version of his pitch and had exactly one student who was interested in this. Everybody else was just kind of buried in work. But one student totally took the bait and got involved with the club and ended up going out to Huntsville, Alabama for their competition. Ended up getting job offers when you graduated. Ended up getting offers, if you want to do graduate work, contact me, and you've got a full ride here if you're interested, right? Networking is huge, right? So you do your classes, you get your good grades, you do your assignments, right? You get strong letters from your professors. But networking is a huge part of where you go along this path. Someone that you meet at some random place, and 2 years later, you're thinking, it'd be really cool to work in this area, and you look this person up, and it's like they know someone who's working there, and it really just kind of it's magical how it can work. And building up sort of a professional network from your peers, from people that you meet at things like that, maybe, or conferences you go to, stuff like that, it all kind of comes back and helps in your journey. So that's my little unsolicited sales pitch. He just asked me to post this somewhere, but I got really excited about this club. So that's my sort of sales pitch. If you're interested in playing around with some of this stuff, go check them out and bring some CS skills to the effort, because they definitely need CS because everything's computer controlled. All right, let's talk about ODP 411. So 411, you were writing a function called parse. It takes one argument, which is a car pointer. It returns an int. Okay, and the idea was when you say how many sticks would you like to take, and use an fgets to read in that line of input from the user, you can pass that input to this function. And it returns one of two things. It returns a flag -1 saying they didn't put in a good answer, or it returns a number 1, 2, or 3 that tells you how many sticks they want to take. And it bundles all of that behavior inside this function. So you write this, you test it, you don't have to think about doing those things. So a few things to note about this. One, parse takes a single argument. If you pass 2 arguments to it, if you write it to accept an integer and a car star, right, it's a totally different function. And if you try to assess that, it's going to give you 0 out of 10, right? It's got to take a single argument. Nowhere in your parse function should you use fgets. Okay, there's nothing in here that says you should read input from the user. Nowhere in here should you use printf, because there's nothing in here that says show something to the user, right? This is, you can think of it as a silent function, okay? And sometimes in precision of English language, we might think of that argument as input to the function, okay? But don't use that word input. Think of well, when I use the word input, I mean something coming in from the keyboard or a file or a command, something being fed in through standard in. And when I talk about output, I'm talking about something going to standard out, printf, typically. This thing that you put in parentheses to parse, that's an argument to the function, okay? So terminology. Arguments are things that you pass into the function. Return value is a thing that parse returns with a return statement. That's the int that will be the value of this function. So if you say x equals parse blah, x will take on whatever the return value is from parse. Okay, so it's kind of like an output, but I won't use the word output for that. And so how do you do this? Use scanf on whatever the argument is, right? Take the argument, call it something. This is a function prototype. So you can put this in a file where you're going to call parse, right, like your main.c, but it doesn't describe what parse does. It just says, takes a char star, returns an int. When you write the function parse, you're going to say int parse parentheses, char star, name of some variable, right, close paren, no semicolon, opening bracket, and then the actual code. And inside that code, whatever you call that variable, you can imagine that that is the thing that parse was called with. So that's the string that you want to analyze. So you go ahead and you feed that into scanf, and you check the return value, and so on and so forth. So here's an example of parse.c. So I call the argument arg. You can call it anything you want. I had a couple of integers, I and ret. I called scanf on that argument that was passed in, scanned with a %d, saved the result in I. Right, we're going to talk about these ampersands a little more today. And then the return value from scanf is ret, R-E-T. Okay, so let's be really clear here. There's two things happening in scanf. One, it's trying to convert this string, arg, into an integer. And if it succeeds, that integer value is going to go into the variable I. Okay, so I will be 1 or 2 or 3 or 10 or -5 or whatever. The other thing that's happening is scanf is telling me, did it succeed in converting? That's going into the variable ret. And ret will be 1 or something other than 1. So if I want to know, is my argument a 1 or a 2 or a 3, I want to see if I is equal to 1 or 2 or 3, right? But before I do that, I want to know, did it convert my string into an integer and store it in I? And the only way I know that is by checking ret to see if ret's equal to 1. If ret's not 1, I cannot use the variable I. Its value is essentially meaningless. So first thing I do is I check the return value, and I decided to say if it's not equal to 1, because at that point, I'm done. Parse has finished. I just have to return a value of -1. So if ret's not 1, I just return a -1. Otherwise, once I'm down here past that first if statement, I know ret was equal to 1. It converted my argument into an integer, and it stored that integer in I. So the next task is see if I is equal to 1, 2, or 3. So you could do if I equals 1 or 2 or 3, right? Or you could use greater than or less than. So if it's I bigger than or equal to 1 and less than or equal to 3, it's a valid entry. I just return I. And if that's not the case, it's an invalid entry, so I go ahead and return -1. And most people had some version of this in their ODP, but the order is really, really, really important. And the fact that I'm using ret here instead of I, and I'm using I here instead of ret, right, is really important. And if you're not sure what's going on with this, write some test code, right? Put away the ODP for a while, and just start writing code that uses scanf. And Doesn't have to be fancy. Right? Perfect junk code here.
You forgot the closing parentheses for the int main, I think.
Yeah, it looks like it. Did I?
Close
The close bracket.
Close the bracket. Close the.
Oh, for the main program, yeah, yeah. Okay, thanks. So yeah, I'm just gonna scan a string, which I've hardwired, scan it with a %d, and I used percent instead of ampersand. Is that your hand? Someone had their hand up. Okay. And then I'm just going to print out I, and I'm going to print out num. And I'm going to throw this code away when I'm done with this. Right? That's why I'm calling it junk code. Or maybe I'll keep it. All right, so a 12 converted to a 12, and it told me that I was equal to 1. That means it got a good value. I tried to convert haha. My number's still equal to 12, but it came back with a 0, which told me the conversion failed. I tried to convert an empty string. My number is still 12, but it came back with a value of -1, which means the conversion failed. So in these two cases, I don't want to do anything with num. They happen to be the same value that I had before, but that's because when it can't convert, it doesn't change num. Then I tried, because my argument was empty, and scanf just does something different if the string is empty. It returns a -1. So that's why I say the way you have to tell if scanf succeeded or not is see if it's equal to 1. If it's different from 1, right? But if you just check to see if it's equal to 0, that'll trip you up. So then you convert a 2, it says I succeeded in doing that, and number is equal to 2. And then I converted 12, haha, and it said that succeeded, my number is equal to 12. Right? Why did it do that? Because scanf only goes as far as it can find something that matches this pattern, %d, and then it stops. So at 8 to 12, happily converted that to a %d and returned a 1 saying, yeah, I converted one integer. Right? So you're allowed to take that as valid input.
What would happen if you did a haha and then 12?
Good question. All right, so haha and then 12, it returned a value of 0, saying it did not do any conversion. And it gave a value of num equal to 12. And that's a bit of a red herring. Right, because if I ask it to convert haha 66, num is still equal to 12. So it's not actually doing anything with the 66. It's starting here. It looks at the h, and right there it probably says this is not an integer. It returns a 0. It doesn't touch num.
So it scans the first thing.
It starts at the beginning, and it goes as far through this as it can and still match whatever the pattern is, an integer in this case. As soon as it got to the h, it said, okay, that's not an integer. It gives up right there, and it never even sees the 66. So let's take this further. So now we're going to scan %d space %d, and we're going to store the results in num and num2, and we're going to take a look at what num and num2 are. So how many people think num2 is going to be 66? How many people think num2 is not going to be 66? How many people believe there's more than 2 possible answers to that question? So let's compile it. All right, so I was equal to 0, num was 12, num2 is some weird number. Because scanf starts here and it says, can I match this pattern? Nope, I didn't. Right, it starts here and it says, can I match this pattern? An integer followed by an integer. Gets to the h, it says, nope, I'm not going to be able to match an integer followed by an integer. It gives up right there.
If you had ended the quotation after the first %d and then put this, could you do a %d and a quotation mark and then another %d and a quotation mark? Would that
No.
change? Okay.
I know what you're hoping, but that does not happen.
Okay.
But just to let us sleep at night, let's try that. So here we scan 436 space 66 as 2 integers, and it returned a value of 2. Why did it return 2? Because it converted 2 things. And the first thing was 436, that got stored in num. The second thing was 66, that got stored in num2. So a couple of takeaways here, right? The return value from scanf is the number of things it succeeded in converting. As soon as it gets to a point in the input where it cannot do the conversion, it quits. It doesn't go on beyond that. The rest of your input might match your pattern perfectly, but it doesn't look that far. Okay, it gives up as soon as it runs into a problem. And my num2 seems to vary randomly from run to run. Right? Why? Because scanf is not loading a value into it. It's whatever the value of num2 happened to be, and I never initialized it. So it's basically a random value. All right, does that help? And again, make yourself some sort of directory structure if you haven't already, where you can save code, where you can save projects, right? Have a directory called scanf code, right? And every time you do something like this for scanf, go ahead and throw it in there. And that can be useful. So I've suggested that you don't use scanf, but let's just play with scanf for a second. So I've got an infinite loop. I'm going to say enter an integer. I'm going to scan an integer, store it in I, and I'm going to print out what integer you entered. Right? What could go wrong? And it'll go back and do this forever. If you call code bad, it'll always be bad. All right, enter an integer 23. You entered 23. Awesome. Enter an integer -9. You entered -9. Cool. Enter an integer, haha. Bang.
Oh, I did that last night.
Yeah?
I'm very familiar with that.
Oh.
Yes. All right, so what the heck, right? And it takes a while to recognize your Control-C. So scanf is not reading from a string, it's reading from standard in, this pipeline that our keyboard is feeding things into. And I fed in HAHA. Okay, haha. And scanf says, okay, let's see if there's an integer sitting in the beginning of that pipeline. It looks at the H and says, nope, there's no integer here. So it'll return a 0, and it'll print out whatever the current value of I is. And it goes back here, and scanf says, is there anything in the pipe? Yeah, there's this thing, haha. Let's see if it's an int. Looks at the H, nope, that's not part of an int. It comes back with a 0. Prints out the value of I, comes back, scanf says, is there anything in the pipe for me to scan? Yep, haha. Let's check the first character, and it just keeps doing that, right? So that can bite you if you're using scanf, because scanf is doing two things. It's doing input and it's doing parsing. Now if we do an fgets, once we say fgets, it's going to read in that whole line which says haha. The next time we call fgets, it's going to read the next line, right? So we're not going to keep reading the same thing over and over and over again. Scanf only ingests input if it succeeds in parsing it. So that can be an issue. And there goes my connection.
Same.
Same?
Yep.
All right.
Second time.
Yeah, I got the spinning. Up there we go. All right. So if it says enter an integer and I say 1, 2, 3, 4, 5, 6, 7, 8, and I hit enter, what do you think it's going to do?
It might loop.
It's definitely going to loop. So I hit enter once, but it went through my loop 4 times.
Because
Why?
you entered the 4 different arguments.
Yeah, so that pipeline, standard in, was filled up with 4 things, separated by spaces, and when it did scanf with a %d, it ingested the 1 and the 2, it found the space, and it said, okay, I'm done. Here's your number, 12. And then it went back to the top of the loop, and scanf said, okay, let's see if there's anything in the pipeline. Yeah, there's a space in the 3, 4, and it read that as an int, and so on.
So it's really easy to mess up scanf.
Yeah. And if you know all these details and nuances, you can work around that, right? But I think it's a whole lot less painful if you just use fgets and then scanf, right? Because it breaks those input and parse functions into 2 separate pieces of code. All right, so let's look at ODP 412. So 412, this is another function you can use in PA2, right? Because what does PA2 do? It says that you can run your program one of 2 ways, with a command line argument that says how many sticks you want, or without a command line argument which says, okay, ask the user how many sticks they want. So ODP 412 basically takes an argc argv, like what you would have in your main program, and it says, is argc equal to 2? And if it's not, it's going to return -1. That's your flag saying there was no command line argument given. Or maybe there were multiple arguments given. If argc is 2, then it looks at argv1 and says, is it an integer? If not, return -2. Is it an integer but not positive, meaning less than or equal to 0? And if so, then return -3. Otherwise, it's a positive integer, convert it to an integer, and return that integer value as the value of this function. So with a function like this, start, right, the beginning of your PA2 can simply be a call to start. You pass argc argv from main, you check the returned value. If it's -1, then you have to ask the user how many sticks they want. If it's -2 or -3, it's an error, so the game's over. Otherwise, the value it returned is the number of sticks you want to play with. You got to tweak this a little, because if you pass multiple arguments, RC will still be -1. So write your start function to do that, right? This is the prototype of the function. So write start, take 2 arguments, and don't try to piece together argc and argv or solve for testing. Just take them from your main program, right? Make a main program that takes arguments int argc, char, star, argv, and then just pass those to start, and you can set those by just running your main program. If you don't type any arguments, argc will be 1. If you type 1 argument, argc will be 2, and argv bracket 1 will be that argument, right? So you can test your code like that. Make sure you check the return value from scanf so you know if it converted or not. Make a main program, test it, run a bunch of test cases. Once you think it works, go ahead and link it in with the test bed ODP 412 main and go ahead and assess it. Make sense? All right. All right, I want to talk about passing arguments to functions and getting values back from functions. So here's some test code. I have a subroutine named sub. It takes an integer. It doesn't return anything. Okay, so the return type is listed as void. I'm not going to return a value. I have a main program with an integer x. I set x equal to 10. I print out the value of x. I call sub, I pass x to my subroutine, and then when I come back, I print out the value of x again. And my subroutine takes an argument, I'm calling it num, and it sets that argument equal to 5,000.
Is the function prototype, does the function prototype need to be assigned to an integer x?
You don't need to name this variable here. You can, and it'll ignore the name.
No, does x need to equal the prototype type function?
What do you mean?
X equals sub x?
No, I'm not returning a value from sub.
Oh, okay.
Okay, so sub just does something, but what it does is it sets its argument equal to 5,000. So there's 2 possible expectations of what's going to happen here, other than the universe collapsing, which is always a possibility. Right, so what's one possibility? One possibility is that when I come back from sub, x will be equal to 5,000, right? Because that's kind of what the code looks like it's doing. It's taking whatever the argument is, it's setting it equal to 5,000, and so after the call, x should be 5,000. The other possibility is that's not going to happen for some reason. So which one is going to happen here?
X is going to stay 10.
X is going to stay 10? Is that the consensus? People always get nervous when I like do things like that because they think there's a trick, which is good because sometimes there is. So no trick here. So what's happening here? This num equals 5,000 has nothing to do with this variable x. Okay, so there's a buzzword here. Oh, that's sad. I have no. Yeah, that would be my camera. I hope we got audio. So there's a phrase here which you're going to think about a lot. Pass by value. So the C language is what we call a pass by value protocol. When I call a subroutine and I say I want to pass x to it, it does not pass the variable x. It passes the value of the variable x. The system looks at the value of x at this point and says it's a 10, and it basically says sub parentheses 10. And down here, it sees a 10. It says, okay, I'm going to set num equal to 10. And then it sets num equal to 5,000, and it returns. And that all has nothing to do with this variable x. Okay? It's not passing x, it's passing the value of x. There's nothing I can do in here that's going to affect x because this subroutine doesn't know anything about x. I could have said sub parentheses 10, I could have said sub parentheses 5 plus 5, or sub parentheses x. It's all exactly the same. When you get down here, exactly the same situation. So that's passed by value, and everything in C is passed by value. Okay. So how do we make this code work so that we can actually get back 5,000 instead of 10? This is where we do the following. We say I'm going to pass the address of an integer. We pass the address of x, and then we say the thing pointed to by our argument should be set equal to 5,000. It's still passed by value, but the value that we're passing is the location in memory where x is stored, the address of x. And down here, num is equal to the address of x, and this says the thing pointed to by num, which is x, should be set equal to 5,000. Ooh, I messed that up big time. So num isn't pointer to an integer. So there we actually change the value of x. So let's throw one more wrinkle in here. Let's print out the value of num in the beginning of our function. And I may get a warning here, but I'm going to ignore that. It says inside sub the value of num is, and it's this weird number. And let's print out the value of num after we make this assignment statement. And it hasn't changed. So num is negative 213 something. And after we say star num equals 5,000, num is still minus 213 something. But when we get back to our main program, x has changed to 5,000. So this is an address in memory. This is where num is stored. It's its actual memory address.
That's where it's X. That's where X is stored.
That's where x is stored, yeah. Yeah, thanks, not num.
Is that the only way to do that? Could you like possibly return the value?
You could return a value, and if you only need to return one integer, don't do this unless you're asked to, right? Just return, make your function return an int, and then just use a return statement. But if you need to return more than one value, you got to start passing addresses of variables, right? And you've already done this your whole life, right? When you do scanf or scanf, what do you do with your last argument? You put an ampersand in front. Why? Because if you don't do that, scanf can't load something into that variable because all it's got is the current value of it. So you pass the address of it. Scanf knows that thing is an address, and it says, okay, let's store this new value at the thing pointed to by that address. So that's why you're doing ampersands in scanf and scanf. So we'll come back to this, and we're going to start playing with GDB in a few days, which is the debugger that will help you figure out what's going on in your C code. And we'll start taking this apart and playing with it in the debugger. But this is all we're going to do in 222. Right? Once winter term starts, we're just going to live and sleep and breathe memory addresses, pointers, addresses, things like that. And it's actually really fun once you get your hands in there, because you're building up structures yourself, and you're putting things in memory in particular places in certain organizations, and it's a totally kind of different but really powerful way to organize information. And it goes way beyond what you can do with an array or with plain old variables. And that's just going to open up a whole world of things called data structures. And we'll talk about things like linked lists and trees and B trees and tries and queues and stacks and all kinds of things. And we'll build these things together with our own hands, and you'll never look at programming the same. All right, so that's all going to hinge on this idea of addresses of things in memory and being able to do what we call dereferencing an address. Take the thing pointed to by this address. All right, so that's pass by value. Yeah, I switched my USB port. I'm not happy with that. So the alternative to pass by value is what's called pass by reference. Or sometimes pass by address. And there, if you pass a variable x to a function, and that function changes the value of x, it changes it in the caller as well. Because in a pass by reference language, by default, you're passing the address of something. And when you refer to it in a subroutine, you're referring to the same thing that you passed. C is always passed by value, though. All right, so questions about that?
Where would we use pass by reference? What languages?
So Pascal, I think, let you do both. I think Fortran was passed by reference. But most modern languages, I think, are passed by value. Probably not.
Isn't pass by reference just a pointer?
Basically, yeah. But you didn't have to actually make it a pointer. It was sort of the default behavior. So it just used the address of it, so a pointer to it. Yeah, exactly. And when we do Java and object-oriented design in 223 and Spring, right, this kind of goes away because everything's an object, and that's something different. But we sort of pass around these big things that include code and data, and it's a different feel. All right, questions? So we'll be saying a lot more about this particular topic. All right, so let me take the last 3 minutes and just sort of touch back on what we finished with yesterday, which was this idea of input redirection. So this was my PA1 stick game. So how many sticks do you want to play with? We'll play with 30, and we'll let the computer go first. And I'm really hopeful that I'm going to win. I lost. Okay. So you're testing your code, right? And it's not working quite right. And you've got a particular test case that you want to use to know if it works. I could do this if I was trying to speed up grading your program, but I don't. I grade them by hand. But here's an input file that looks a lot like the inputs that I might type in when I was running my stick program. First I tell it how many sticks, then I say the computer goes first, and then I list how many moves I'm going to make. And I can say stick less than input, and instead of reading from, that's not going to work. Instead of reading from my keyboard, it's reading from this file. And it goes through and it plays the whole game, but it used the input of that file as the source of standard in. And here's a bigger file where I had some typos deliberately, so I mess up the number of sticks a few ways. I mess up who's going to go first. I make a few single mistakes in the number of sticks I want to take, but I don't make 2 in a row. And if I run this, right, it plays the game, and I can see that it handled all those conditions correctly. But it's also scrolling off the screen here. And if I want to actually look at this, I could say pipe the output into more. And now I'm looking at the output one screen at a time because I've got this function called more, right? So it's reading input from my file, it's taking the output, it's scrolling it one page at a time. And I can scroll through like that, or I can hit a space bar and fly one screen at a time, right? And that's just kind of typical of how you can start using things like input-output redirection. Right, the other option would be I could take this, and I could put the output into a file called output. And now I could mail that to someone and say, hey, here's what happened when I tried running the code, and they can look at output and see exactly what happened. All right, so we'll talk a little more about fun Unix things we can do along the lines of input-output direction, a few more commands, and I think I'm going to spend some time talking about GDB. So probably tomorrow or Friday. Today's Tuesday. Tomorrow or Thursday, we'll get into GDB.